All right, so the following question has two different ways to solve it because we have two different ways we end up talking about exponential growth and decay. Let's just look at this question to start with. Um, it says a wolf population is growing exponentially, so they're telling us that we had an exponential model. They're telling us it's growing, so it's exponential growth. And then we keep reading. In 2011, we had 129 wolves, and in 2013, there were 236 wolves. What 2 points can be used to derive this? Write the equation. So lots of ways you can write this particular question and have a completely correct answer. And I don't even know what the OpenStax book wants as an answer because I didn't bother to look at their example. But I'm going to go through a couple of ways you could handle this. So one would be to use the exponential function that we saw in the previous example, this idea of f of x is equal to a times b to the x. That's one form, right? So we're going to find eventually that there's another version of this. So we're going to get this one that's mostly thought about in terms of population. That one was a bit long, so I might actually edit that one out. The other version, you'll sometimes see it uses an e, and we haven't actually talked about e yet, but my goal will be, oops, I need the initial population. My goal will be to bring back this exact same question to tackle when we look at this format as well. So we're going to focus right now on the top one because that's what we're talking about. We're in the basic exponential functions. We haven't really talked about our exponential modeling that we get with the e yet, but it can be written either way. Another way that you're going to see some issues here is that we have lots of different ways we could write out the points, right? Because it does ask you what 2 points can be used. And we can see we've got an input and output from two different time periods. So you could use 2011 as your first time point, and you could use 129 as the output in terms of the number of wolves. If you did that, you'd use 2013 and 236. Come on. Or I don't like those. Those are big numbers. They're not as joyful to me to use, especially using them as exponents. Like, ugh, I hate that. Typically, I like to just set one of these as times 0. That just makes life a little prettier to me. So I might say t is going to be years since 2011. And I'm going to use 2011 as my initial, right? That's starting point. So if I'm going to do it that way, then that makes my life a little bit nicer in terms of the numbers I'm using. 2011 is the 0 year 0, and then 2013, that is 2 years later. So we had 2 comma 236. I just find this to be a little easier to work with in terms of values. So I might set it this way, but it really depends on the question and what it's having you do. This one, I probably should be using 2011, 2013, but they bring me no joy. So I'm redefining the question because it's just for a video. I'll have to turn it in. So now what we would do is we'd say, okay, well, if we have to use this formula, if we're going to use this formula because it's the only one we know about at the moment, we could set this up, right? We could say, okay, well, now we have two equations. In fact, I made our life super easy by using 0. We know 129 is equal to a times b to the 0. You can see how this would suck a heck of a lot more with 2011. Oh, that just means that a is equal to 129, which makes life so much easier when I'm moving to the next one. Because now I can just say, okay, well, 236 is what I got out if I plugged in 2. So that's 129 times b to the 2. So if I wanted to know what my base was, right, to get there, oh, hopefully it's still recording me talking while it's frozen. I can't remember if it does. So if I wanted to solve for what my base was, I would just need to, looks like divide here. Right. So I'll divide each of these by 129 to get that b squared by itself. This is not something pretty when you divide it out, so let's just leave the fraction there. That's a mistake a lot of students make, is that they want to like round interim steps. And if there's any rounding to be done, especially an interim step, do not do it. So now I'm going to have b squared. I'm just changing the order because it makes me happy. It's equal to 236 divided by 129. My shit has frozen for the fifth time while making this 5-minute video. 129. And then to get b, I'm just going to square root. And I don't have to worry about negatives here because we know our base has to be positive. So b is just equal to whatever the heck that square root is. So the square root of 236 divided by 129 is equal to 1.35. And that is bigger than 1, so we are getting our exponential growth that we expected to. So b is equal to, I'm just going to go ahead. Now I can round without feeling too bad about it. So if I wanted to make an equation to represent my function over time, I would say n is the number of wolves. And if you put in time, it's going to be 129 as my A. My B was 1.35 and some change, right? If I was going to be good about this, I would not round that, but I'm going to be lazy. I'll do dot, 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 to the T. And I need to make sure that I've said that T is the number of years since 2011. So that is my correct answer to that question. But like I said, it's just one of many correct answers. If you plugged in the thousands, you're going to have a different answer. If you plug in thousands, your answer is going to be really similar in terms of the multiplier. That shouldn't change, right? Our repeated multiplication doesn't change, but what would happen is we would have taken and shifted 0 over to whatever the heck year 0 was. So we would have taken and done a horizontal shift to the left of 1,000, or I can't even think right now if it was left or right of 2,000. So this will have just basically a t minus 2011. But then, of course, it's not in the right format, so there's just going to be a big fraction going on in the bottom. So that makes this a lot messier, which is why I'm choosing to use 0 and 2 as opposed to 2011 and 2013 for my work.